evening. Thank you for opening this. Okay, so good evening, everyone. So welcome back to 58. Yeah, so today's agenda, we will discuss about prioritization. Okay, I think you can follow the slides and all the other resources material in the Moodle of Prevalent. Uh, is there any of you still have a problem with the model to access? No more? Okay, good. Okay, so let's start with our first slide of prioritization. Can you see? Yeah, right. So I will start the prioritization with personal, okay, uh, activities, and then we can go to the transportation part. Okay, so uh, we will discuss first about quadrant, what you already know, yeah, importance and urgency. You probably have used this. And then we try to find what is called optimum prioritization. Yeah? And then we discuss more detail on prioritization of transport project. Okay, so so first thing first, yeah? Why do we need prioritization, right? Of course, we want to make an informed decision, right, about how to allocate our limited resources. So, this case, what is the limited? Probably time is limited, budget, or probably number of personnel, or person in our division is also limited, and so on. Okay, so we have a limited resources, so we need to allocate our limited resources to achieve a greatest impact. That's the goal of prioritization, right? So, and we want to align our resource allocation, okay, with our own long-term goals and objective. And then you want to identify which area, okay, that you want to improve or expand so that you can get the greatest impact. Okay? And of course, you can also manage the risk. And using this kind of prioritization, okay, you will have clear accountability, and then transparency about decision making. Without making it systematic, okay, then you will have a problem to say that this is already passed through systematic way to prioritize. Say you have several projects, okay, and say you just want to finish certain project of your own without certain criteria, then it's a personal project that you impose into public, for example. So I give you an example. Uh, Last time I worked in certain city, okay, and the officer want to finish the budget, yearly budget fast. So that they finish fast, they said, okay, let's in that case let's build a bridge because bridge is very expensive. So let's build a bridge so that we can finish it fast. So in this case, there is no really real accountability because his decision is only based on his personal interest, okay, rather than uh, for the real public. So, of course, I rejected that, and then we start to discuss about this kind of systematic prioritization, okay, uh, with all the alternatives that we can put and then criteria. Okay, so first thing first, okay, let's do something personal. Okay, you know this, right? Importance urgency quadrant. Okay, so we have only two criteria in this case. Okay, so first is called importance. Okay, and then the second is urgency. So if your task or your activities, okay, is actually urgent and important, then you give priority A. Okay? If this is important but not urgent, so you give priority B. Okay? And if it is not important but urgent, you give priority C, right? So, and then if not urgent and not important at all, probably just pleasurable or entertainment, then you can put this as priority D. Okay? So, first practice, I want you to do this. Okay. So, just list down in Notepad or in Excel or in Word, whatever. Okay, list down the activities or tasks that you wish to do for your work. Okay, next week. If you don't think of next week, probably tomorrow. It's fine. Okay, so and then you set priority and to be A, B, C, or D, and for each the task or each activity. Okay, and then you estimate, okay, how long will you do for each activity, okay, and then you give the value. Okay, 0 is the worst, 100 is the best for each activities toward your personal goal, of course, right? These activities always have uh, objective. It is your own person. Okay, and then last one, you said how long will you do some activities, and then you show, okay, which activity should be priority. Yeah? Of course, you see there is a resource, in this case your time, your own time, so it's limited, right? In 1 week, how long you can work? Say 8 hours per day times 5, that should be around 40 hours. Or you want 12 hours per day, that's fine. So multiply by 5, you have 60 hours. If you work 16 hours per day, you multiply. Okay, that's the limitation of your time. Okay, okay, so can I give you 5 minutes to do this? Then you can, some of you can share, and not all, if you are willing. Okay, if not, that's fine. So, but keep that uh, task and priority in your mind so that later you will do uh, more computation later. Okay, 5 minutes. Now, go do it. Your own task for next week or for tomorrow. That's fine. Okay, so uh, this is interesting. Okay, because now you can start to see. Okay, when you do this kind of very simple activities. Okay, planning for your own daily, right? So usually I do this in the morning. Okay, so or in the weekend to plan for the next week. Okay, so very simple way to plan and uh, easy to use, right? Just A, B, C, D, and then the time. Okay. Now, using important and urgency quadrants, okay, uh, very simple to do, okay, and probably useful, but there are some cons, right? So it assumes equal weight between the importance and the urgency, yeah. And then there is no actual time component there. Okay. And yeah, usually, okay, if you have a very long-term uh, goal, okay, you want the long-term important tasks should be higher priority than the short-term urgency. Yeah. In that case, you probably want to put priority B higher than A. Right. So some people may say, okay, this is only two criteria, which is only importance and urgency. Probably we need more criteria, and then we may need to put different weight for each criterion. So I listed there in the slide. Okay, so you can add your own criteria. Okay, whether it is importance, urgency, or you can put time-based priority, right? So you can say this is a very short term. That means you must do within today, or just short term that you must do within this week. So midterm for personal use, that means oh, I should do within this month. Okay, okay. And long term, I can do it within this year, or very long term, probably I can do it within the next 5 years. And of course, you have lifelong wish that you want to achieve one day in your life. These are the other way to show your priority. At the same time, you can have other your own criteria. Yeah? So these are the you can read on your own. Okay? Criteria that you can put here: necessity, usefulness, simplicity, capability, interesting, curiosity, satisfaction, okay, or the cost probably, or benefits for personal things. No? And probably it will give you some confidence, right? Okay. Now, I want you to read this first. This is interesting. Yeah. This is something that you have probably read in social media, right? Okay. So my question to you is this correct or not? Okay. Is this optimum or not? Okay. So let's I want to discuss this. The strategy suggested by the story, philosophy professor a while ago, is to fill up our time with the most valuable and the most important things first, isn't it? And then my question is the above strategy is actually optimum strategy in your life. Yes or no? Any comment and any discussion at this point? Go. Do you agree with that or you don't agree or anyone? Yes, Paulo.
Sir, good evening po and class. Um,
Hmm?
Good evening po. It's somehow true and somehow not true. I'm in the middle ground here. Well, practically because it's good to have big goals in life and your achievements and your overall overall strategy. But you cannot do
Hmm.
small things if all you're looking at is the bigger goal and all your focus is on the bigger goal. You have to break down those goals, or you have to break down that goal into smaller steps or smaller pieces, and then you have to break those down again into smaller pieces gradually to gradually achieve your most your the bigger goal. I think that's how things should be.
Oh,
That's it.
so let's try. Okay, probably some of you, okay, or most of you will agree with the wisdom, right, from the philosophy professor in the story above, because the way it presented was quite nice. Okay, so let's try to compute, okay, on your own. Okay, uh, using the value that I will put after this. Okay, so let's practice this. Okay, so I have only 10 hours a day, right? So you have A, B, C, D, E, F, G. Okay, this is your effort to do. And then these are the important values. So of course, 10 is the highest, 1 is the lowest. So you can type this in your Excel. So remember, the total is maximum is only 10 hours in a day, right? These are the total. So can you develop a strategy to get the prioritization of these tasks? Anyone? Yes, James.
Good evening po. Uh, maybe we should I for myself I should focus more on the
I cannot hear
greater.
you.
Hello. Can you hear me na po? Hello. Hello. Can you hear me po?
Can you repeat? I think you're
Hello.
mute. Can you unmute?
Dilig na po. Hello.
Go ahead, James.
Okay. We should focus more on the high importance value with little effort. For example, as shown in the previous shared slide. For example, the activities A and B, they have the higher importance value, but it requires a little less effort. So, ayun po.
Can you hear his sound?
Yes, bro.
Setting. Oh, I cannot hear you. A and B have important value with less effort. Okay. So if you use A and B, okay, if you use only A and B, okay, so total effort is how much? 8, correct. And total important value is 19. Okay.
19.
So if your is this the best? Is this optimum? So highest that you can achieve, okay, under the constant of 10 hours, if you use A and B, you will get only 19, right? So is there any better strategy? What happens if I put like this? A, B, and okay, the one that can reach 10. That means F. A, B, and F. Okay, that one total is 10 hours, right? And then important value is 10 plus
24.
9 plus 5, so 24.
24.
Is that better?
Yes, bro. Yes.
Huh? Is it better or not?
Better.
Okay, so can you find better combination? Is this 24 is the highest that you can achieve using your method? Anyone have better answer than 24 maximum total values? Uh-huh. Okay, type what other values that you can achieve. Based on the important values, no. So Ben, B and D. Oh, okay, go. B and D is 9.5 hours, and the total is only 17. That's lower than A and B, right? So is there anyone can reach higher than 24? So far, our best strategy is A, B, and F, which is 24. Can you reach higher than that? Hmm. Anyone? A, C, oh, A, C, E, F, A, C, E, F, A, C, E, F is also 24, okay. A, B, D, hmm. Ah, there, yes, 29. Ah, good. 29 is the optimum value. Okay. Question, how do you get that? Guessing, right? Guessing only? Computing? Oh, how do you compute? Computing the effort. Manually, you do compute, right? So, okay, now I want to show you uh, the way to do more systematically. Huh?
Hello, sir. Sir, may I volunteer?
Okay, so,
Ay, di ako na-
can you see this? So, what the if you use most important values only, this is, let's call this strategy one. Okay, you sort the task based on the important values, and then you select the first few activities until the time is up, isn't it? So in this case, you have only 19. Yeah? Total time is 8, and then total value is 19. Okay, this is not optimal. So if you fill up our time with the most valuable things first, this is the strategy of the philosophy professor a while ago, right? So you will get A, B, and F. Okay, the total value is 24. Okay, so a little bit higher. Okay, but this is not optimum. Yeah. So if you only you like to do challenge, okay. So if you do most time only, so again you will get only total value of 16. So this is not good strategy. Yeah. Oh, if you want to do the easiest first, okay, total time 8 and then total value is 23. Again, this is not a good strategy. Okay, so or you can fill up the time up to from the higher values. Okay, so you do the most important value, and then you after you eliminate some difficult effort. Okay, so for example, you can set a threshold, say 2.5 hours. Okay, so anything beyond that, okay, it will be too difficult. You can do that. Okay, if you set 2.5 hours, you remove activity B and D, and then again you get result is C, E, F, and G. Total time 8, total value 23. Not better. Okay. If you go fastest and then higher value, this is selecting the fastest and the highest value first. Yeah. Okay, the least time and the higher value, yeah, your aim. Okay. Question is this the really good strategy or not? And you can check. And the result is actually, oh, a little bit better, 27. Okay. But this is not optimum. So question is how to do optimum systematically, right? Okay, so question, what is the optimal strategy? I tried 6 different strategies. All of that is not optimal. What? Because the optimal value is actually 29. Okay. So question is how do we get optimal strategy okay, using a technique, yeah, and analysis, right? Is it interesting or not? Okay, so the technique is called knapsack. Okay, so in the knapsack, you have a hiker packing on his knapsack to go to the mountain. Yeah. So he has an object. So this is the task that you want to do. Each object, okay, I have say we call it I. Okay. Each object I to n has certain weight, right? So and then it will give him a certain profit or comfort or utility or benefit. Yeah. So we call this VI. Okay, and then of course you have some limit, okay, capacity limit that you can carry. So I put C here. The question is which object should he brings to maximize his total benefit, right? So this is called knapsack problem. You can Google it, yeah, by this keyword knapsack problem KP. So you can have this is called linear programming problem, yeah, integer programming. Aha, you go to the mathematics, okay, but don't worry, this is what you will do. So you maximize the value multiplied by the task, okay. Xi here is 0 or 1, okay, and then subject to constraint of the weight, the cost, multiply the x, and then must be less than c, okay. So you are given the v, W, and C. So this is the value, this is the cost, the effort a while ago, W is the effort, and then C here is the limitation, okay, like 8 hours, 10 hours in a day. So you want to find the decision whether you want to include okay, this object into your knapsack. Okay, so in fact, KP or knapsack problem is one of the simplest but non-trivial integer programming. Yeah, with binary variables, okay, with only single constraint and only positive coefficient. Okay, so it is quite difficult problem, especially if you have many activities. Okay, so I developed this unprecedented software tool. Okay, let me show you. So I will share my Excel just to show. Okay, so add-ins. So I have antecedents here, so I generate examples, right? And these are the number of hours, activities, and effort, right? And prioritize. Okay, it computes by itself, yeah? So based on this, it will compute that activity C, E, and F, okay, should be the priority. Okay. So we can input that a while ago. So instead of doing the software, you can also do it manually. Let's do the manually. Okay. I will create the new sheet here, and then I will include the value a while ago, right? So we have activities of A, B, oops, okay, A, B, C, D, E, F, is that correct? And G. And then your effort is, and your value. Okay? So you include here effort and value. So you have 3, 4, 2.5, okay, 4.5, 2.5. Is that correct? 2 and 1, right? And then you have 10, 9, 8, 1. So this is 9, 8, 7, 6, 5, and 4. Okay, so this is the data, right? A while ago. So what you will do,
3, 5.
okay, to do this is you create a decision variable. Okay? You create a decision variable X here. Okay? I will put this decision variable B effort is 5. Oh yeah, okay. Thank you. The decision variable is X, and then this is W, I. This is XI. Yeah, decision. Okay. Decision mean you will include or not include, right? And this is what is our value one. Effort of the, so this is the VI. VI. Okay, so to compute, we need to compute the VI multiplied by XI. VI XI, and then WI multiplied by XI. Okay, so let's compute that. Okay, so the xi here, you can put any number. Okay, so I can put 111. Remember, this is the one that you want to find. So I put yellow. Okay, so then I multiply this with V. Then this one, I multiply this decision with W. Okay, I copy this down. Okay, and I got the total. Okay, total should be sum, isn't it? So you get the sum. Same thing here. Got this? So I will color it differently so that you will see. So let me color this green. Let me color this blue. Okay. So what we want to do, okay, we want to maximize, okay, maximize the sum of vi multiplied by xi. Okay, subject to constraint. Okay, the sum of wi multiplied by xi should be less than equal to c. Yeah, c in here is the 10 hours, right? The limit c is 10 hours. Again, this is given. So let's put different color. Okay, and then of course xi must be binary. Oh, up to here. Can you make it? Okay, then what you will do, you go to the Excel, you go to option, okay, and then add-ins, yeah, and then go, okay, and then there, solve for add-ins, and you check this one and then click OK, and solve for add-ins. Can click OK, then you will have in your data, you will have solver. There. Right. So let's set the objective. The objective to be what? This one. X. Yeah, it's 13. And then by changing the value, which is the yellow part here. Can you see it or you cannot see it? Wait, I will share the whole screen so that you can see.
Again. Ito ay
Okay.
set objective.
And then you add the constraint at where's my constraint? Oh, there. Constraint. The constraint is you want to get the sum, right? This one should be less than 10 hours. But this decision variable must be binary, bin. Okay, and then click OK. There, you will get this, and then you just solve. Oh, found the solution. There, you get 29. And 1 means this is the one that you need to do. And 0 means don't need to do. Clear? So now, okay, you try this and then now you solve your own problem. A while ago you have your own task, right, for tomorrow or for next week. Okay, you do the same thing. Okay. So once you finish, you can share probably this. If you have any problem, you can just ask me also. Okay. Go ahead.
Hear me?
Yeah, I can hear you. Okay. Go.
Okay. So,
Okay. You are using sulfur. Right. Very
yeah.
good.
So for the objective, we set it to the total sum of VI multiplied to XI,
Okay.
and then maximum value by the changing variables of the decisions
Yes.
XI. And then the constraints were
Final.
the XI should be binary, and then
The total of eight.
so is must be less than or equal to 10 hours limit C,
Correct. Correct.
and then solve.
Okay. Excellent.
Ta-da!
Ta-da. Yeah. So interesting, right? So instead of doing it the what is that? Unsystematically, you try all the combination. Okay. So the spreadsheet can help you to do that systematically. Okay. Anyone have problem with this? No more? Okay. So you can practice to prioritize your own daily tasks every day, right? Or weekly plan, right? To be more optimum. Okay. You try first so that you can give me comment. I I tried this many times with other students. They will give comment that, hey, this is not what I expect. Usually like that. You can try. Try to do the same for your own activities for tomorrow and next week so that you can see what the optimum value. Okay, so the algorithm will not select the highest value. And the result is not unique also. Okay, it can, if you run with different initial value, it will give you different answer. Anyone else want to share? Okay, so you can also try the practice there in the slide, okay, about the hiking. So if you want to hike and you can carry only 9 kilo, okay, and you have 5 items A, B, C, D, E, okay, and you wish to bring, okay, so which item should you pack so that the total value is the maximum, okay, subject to the weight restriction, okay. So the one that I put in the slide, I set up the initial value, right, and then the same, yeah, W I multiplied by xi, vi, and multiplied by xi, and then you do the same thing. Total budget is 9. Okay, that you can use the solver to solve that, and you can get the result as well. Okay, so you will get only what the item C and E should be included. In this case, the others no need. Okay, so now let's do the different prioritization of different question. Okay, say this is like a project, okay, or a stock investment, right? So any project or stock investment in here always have costs and always have benefit, isn't it? Huh? So say you have certain cost per stock, and then you have certain return of investment per stock. Okay. So now the question is, how many stocks should you buy for each symbol? Okay. Again, we use knapsack problem. Yeah. So I will put a story like this. Yeah. A wealthy individual or institutional investor have certain amount of money, C, okay, which is available, which she want to put into profitable business project, right? As the basis of her decision, she compiled a long list of possible investment, okay, including every investment that require amount WI with expected net return VI over a fixed period. Yeah? For example, 1 year or 1 month. Okay. Of course, the risk is already included here in the VI. Okay, so let's practice this exactly the same thing. Okay, so you have say $10,000 for a capital investment. Okay, and say you have a list of investment with this A, B, C, D, and E. This is the cost, and this is the net return. Yeah. So the question is, how much we should buy A, how much we should buy B, C, D, and E. Okay, so clearly this is not binary. A while ago was binary problem, right? So in here now we ask how much we should invest in A to buy stock A, how much we should buy stock B. So let's put it in the formula. Okay, exactly the same thing like a while ago. Can you see? Okay, so VI times XI subject to constraint WI times XI. Okay, the only difference is this. Okay, now you have XI is not binary but an integer. Okay, so the XI is now an integer, okay, with 1 to n. Okay, so again, you are given the value. This is in this case the net return or the benefit. You have the cost for each stock in this case, and then you have the limiting of the budget C, and you want to find how many stock for each how many share for each stock symbol. So initial setup, you just type WI, and then say you set all 0 or all 1 is the same. Okay, and then you multiply, and this is the total budget, right? 10,000. Okay, and then you do exactly like a while ago. So you get the total value. This is the total value, the green. Okay, and then you want to maximize, changing the cell XI, the one in yellow. Okay, and then the total cost must be less than the budget, and then this is the only difference. Okay, the XI must be integer, yeah, not binary anymore. Then you solve. Okay, try to do it so that you can see. And the result is something like this. It is interesting because you see, based on this value and cost, okay, we don't need to do A and B, we don't need to do E. In fact, we need to put all money, almost all, yeah, in 31. We need to buy D stock for 31 and then C stock for 4 so that we can get this budget. Quite interesting. Okay, okay. Try it first, and then I want to see some of you to share your work. Is this kind of problem interesting for you? Right? Very common, right? You have the cost, you have the benefit, and you have certain limit. You want to prioritize, okay, including the projects. It's the same. A, B, C, D is just like the project, the stock, whatever. Yeah. So of course, if project become binary, yeah, yes or no. Okay. In this case, stock, so you can put as integer because you can buy more than one. Right. Yes. You want to share your screen? Oh, cool. Happy. Wow. Super fast now.
Hmm. Um, so the objective
solver.
is the total maximum total value
Correct.
here, and then changing is this xi. The constraint is the total cost must be less than or equal to the budget, which is which is 10,000, and then xi is integer.
Correct. And you get the result similar to mine.
Yeah, similar.
Very good. So anyone have problem? So what do you think about this technique? Uh, what is the probability that you will use in your life? So I give you first a personal problem, okay, your own daily activities, so that you can get more interest because this is your personal interest. Okay, of course, eventually you can apply for any project, right? Including your own daily activities. Okay. So then, yes, Angelo, you want to share something or you want to ask or keep going?
This can be this can be this can be used in logistics problems where
Correct.
you have different options of distances and cost of
Transport.
gas
Yes,
or time
correct.
to optimize the logistics, sir.
Yes, that's also correct. Right. So exactly. Yeah. So this is very helpful, right? Because the algorithm help to sometimes I also surprised. Oh, I did not think of that way. Okay. Because the algorithm is actually give us surprise result. Okay. Uh, but of course, because we are the one who input the data, okay, the value and the cost. Okay. So if we don't want it, so we can just change. Okay. Uh, at the same time, it gives us some kind of feedback. Okay. The algorithm give us a feedback. What kind of value that we put there, right? Is that really valuable for me? For example, this activities is really why not selected? I want this to be selected, but this is not selected by the algorithm, right? For example, if your time is actually very big, okay, and your value is just 10, 9, and 8, okay, the value 10 will not be selected if the value, the time is actually very big. In that case, you start to reevaluate your own value that you put there. Okay. Okay. Any other comments? Is this the first time you are doing this or yeah? Okay. So I hope this is useful. Okay. Mm. Slides. Okay. So with this, okay, you can also apply. Yeah, this is logistic company. Okay. Uh, if you are a dispatcher of cargo airline, so you want to decide the load package on particular plane, for example. Okay, of course, each plane may have weight, each packet have weight, and every airplane have the maximum capacity, right? And then you can have the value. It is the rate per weight unit charge. Yeah? So that is the one. Of course, you want to maximize your profit. Okay, as a company. The same thing, you can also apply this to production. Yeah? So you can read on your own. These are the sample of application to other field. In the same problem, okay, as long as you can have the cost and the benefit. Okay, the cost and benefit you can also put it as demand and supply. Okay, start to think in generic term. Okay, then you can apply this to many other problem in your life. The same technique. Yeah. Yeah. So in academic, you if you have n questions, okay, and then you want to reach a certain total, which is maximum, say 100 points or 150 points. Okay, so we can also set this. Yeah. Anyway, you can read by yourself this one. So the technique is clear, right? Our first technique. Okay, so how about for transport project prioritization? Okay, so in prioritizing transport project, okay, try to think in terms of numerical data, yeah, objective criteria, and then you want to run the project, of course, based on the same thing, yeah. So benefit, cost, and the impact. So in that case, you start to define, okay, what is the evaluation criteria? Because different criteria may have different impact, isn't it? Different result of prioritization. And then after that, you collect the data, yeah, for each project. Yeah? How much is the cost? How much is the benefit? Isn't it? Yeah. Later on, we we can go to the detail, for example, in terms of the cost and benefit in financial, or in other method. Yeah. So, and then you decide the weight of the criteria. Yeah. So each criterion you set the weight, okay? And then you set the score for each project, and then you calculate the total score. Yeah. Once you get the total score, of course, now you can run the project and adjust, yeah, or review. So these are the usual steps, I guess you know. So for the evaluation criteria, remember when you start to create the evaluation criteria, you must put this criteria with respect to the goal of transportation planning process. Yeah, these are example of evaluation criteria. Probably you want to talk about the cost, expected travel time, saving, yeah, projected ridership, for example, safety, right, environmental impact or social equity. Okay, and aside from quantitative approach, you can also put it as qualitative factors. Yeah, so qualitative factors are equally important for decision-making process in transport project. So you can include, for example, community sentiments, culture, okay, the need of marginalized or underserved community. Probably you want to include aesthetics, okay, or political will, right? Some creative solution or innovative solution, or adaptability of the project. So these are all qualitative factors. Okay. So later on, I will show you how to do the technique to evaluate qualitative factors and quantitative factors as well. Yeah. So we can quantify. Eventually, you want to combine them together, right? So you can quantify the qualitative factor also. Okay. So sometimes we said, okay, qualitative is subjective factors, which is harder to measure, okay, consistently, but it is also important. So in this case, you need to balance, yeah, quantitative and qualitative assessment, okay, and then we can do some scoring or some distance and some rank analysis. Okay. Once you have that, so you can weight the criteria, okay, and then the weight should reflect the priority of the transportation planning process, right? Okay. For example, if you want to improve the safety as a higher priority, then safety criterion should put higher weight. Okay. Once you put the weight of the criteria, then you can do scoring for each project. Okay? The most important there is consistent. Okay? Meaning, or if you want a higher score reflect better performance, okay, so the cost means lower costs, right? Should be better, not the other way around, right? So the consistency of the scoring is important. Okay? Well, for the gain, you want higher. For the cost, you want lower, isn't it? Okay. And then once you do that, you multiply the score for each criterion with the weight, and then you just sum the value. Okay. And then you calculate the total score, and then you run this. Okay. Okay. Of course, the project with the highest total score will be considered as the top priority. Yeah? So I have in Moodle check. here you have NCDM calculator. Go to this website. Okay. So first you need to select the number of alternative, okay, the number of criteria, and then press next, and then after that you can rename, okay, and then you fill up the score. So here, for example, you have 5 alternative, you have 3 criteria. Just put next. Once you put that, say the criterion, what is the name? So you can just put, for example, this is the cost, right? This is probably what? Convenience. Okay. Convenience. Okay. And this is probably comfortability. Example only. Comfort. Okay. Then you set the weight for each criterion, whether, oh, I want cost is 2 times higher than convenient and comfort. That's fine. Okay. Then click the next. Okay. These are the example of value that you can set up here. And then when you calculate, you get the weighted sum. Okay. This is basically 60 times this 0.5, 83 times 0.25, and 96 times 0.25. Okay. This is the weighted sum. And then the rank, okay, the highest is rank 1. Is this clear or not? So you have in here, we call this MCDM, multi-criteria decision making, very simple technique, right? So you have several alternatives, okay? And you have several criteria, okay? So in here, cost, convenient, and comfort. And then for each criterion, you put the weight, okay? And then you can get the scoring. You can try on your own and give me comments or feedback. This is the simplest technique in MCDM. Okay. So you set the criteria, okay, and you set the alternative project scenario, okay, and then you set your own score for each project, for each criteria, and then get the total score and you run that. Once you do that, and then you will say, oh, probably this is not the score that I want. Okay, you start to adjust. Okay, and the question is whether you see the rank reversal or not. Go ahead, you just try and give me feedback. Okay, so any comments? No comments. Okay, so in that case, let's discuss the next slide there. Next slide is about measurement of scale. Okay. Again, this probably you already know. Okay. I need to show this so that can you see my screen? Measurement of scale. Okay. So if you have data, whether qualitative or quantitative, okay, we can classify the data into two parts. Each variable, okay, we call this qualitative. Basically, we have nominal and ordinal. And if your data is quantitative, that means interval or ratio. Okay, before we discuss this, are you familiar with nominal, ordinal, interval ratio? Wait, tell me what you are familiar with. Anyone? Hmm?
Prof, can I answer?
Yes, Katrina.
For nominal, it's the type of data that can be categorized.
Correct.
And then ordinal is data that can be ranked.
Correct.
There's ranking involved. For
Correct.
interval, it can be, there's a kind of spacing or,
Correct.
and then for the ratio, it involves like for example, height, age, weight,
Very
and
good.
there's
Yeah.
a true zero for the value.
Excellent. Excellent answer. Yeah. So very good. So we said qualitative data. Okay. A while ago we talked about culture. We talked about many variables that is actually qualitative. They are all basically either nominal or ordinal. Okay. And more objective values are quantitative. So basically interval or ratio can be ordinal also or nominal. Okay. So when we say qualitative data, that qualitative data is the data that can be placed into distinct category. Okay. So sometimes can be arrayed into meaningful order. Okay. But qualitative data, in any qualitative data, you cannot do arithmetic operation. You cannot do multiply plus minus. Okay. Example, you can put blood type of the person A, B, AB 0. Okay. This is nominal, right? You can also put assignment of evaluation, either fail, pass, good, excellent. This is ordinal. Right. Okay. So, and next, quantitative data, okay, unlike the qualitative, okay, quantitative data are numeric in nature. This means they can be run in order and they can do some arithmetic operation. Yeah. So quantitative data can be classified into either discrete or continuous. Qualitative data is always discrete. Is that clear? Qualitative data, a while ago, this one must be discrete, but quantitative data can be discrete or continuous. So discrete means countable. Okay, discrete means countable. So the data cannot assume all the values. That means finite and countable infinite. Okay. So integer is countable infinite. It's countable. Okay, so binary attribute is also countable. So example of these are zip code counts, okay, number of words in the document, number of children in the family. So these are discrete data. Okay, continuous data are real number. So, so uncountable. Okay, the value usually obtained by measuring a real number or a floating point. Okay, so example is temperature, height, or weight. Okay, so based on that, so when you do a questionnaire survey like this, okay, you usually talk about nominal, ordinal, interval, and ratio measurement of scale. So we have 4, right? Okay, so the first two is called qualitative. Okay, the last two is called quantitative. And this is the order, you see. The highest is ratio. Okay. And then below that is interval, and below that is ordinal, and below that is nominal or binary. Okay. Why I said that? Because when you do a questionnaire survey, okay, and you already set in your survey, your data must be ordinal, right? Or for example, income. In here, look at this. Age is 19 or younger. This is basically ordinal, right? 65 or over. So this is ordinal, right? So when you do ordinal questionnaire like this, yeah, you cannot make it into interval. You cannot make it into ratio. You already lost certain information in the data because you already set initially already ordinal value. From the ratio type, you can put it down into interval. From the interval, you can put it down into ordinal. From the ordinal data, you can put it down into nominal, but you cannot put it up. From nominal, you cannot make it into ordinal. From ordinal, you cannot make it into interval. Okay? From interval, you cannot make it into ratio. Why? Because once you put it down, you already lost information. Okay, I will give you example. Say you have income. That's your variable. Your attribute is income. Okay, so how much you ask in the questionnaire? Okay, how much is your income in the ratio type? Then should be in US dollar or peso. Yeah, that is ratio type. For example, the value is 25,000 in a month. Yeah, or 120 pesos, for example. Okay, so but if you put that into interval, that means you have equivalent interval. So for example, at 0 to 5,000 is 1. Okay, 5,000 to 10,000, 2, right? 10,000, 15,000, category 3, so and so on. So you are in category 5 or 6. Okay, that interval. So from the ratio, you can put it down into interval. You can create interval for the income. Okay. You can also put it down into ordinal or low income, okay, medium income, high income, isn't it? Okay. Okay. The boundary between that is you are the one who set the boundary. So as long as it's consistent, no problem. Okay. And then you can also put it into nominal. For example, into binary, have income, no income. Right? So imagine in your questionnaire, you are already putting into ordinal. Yeah, something like low income, medium income, high income. Example. Can you get the actual income? No, right? Because you already lost information. You got it on. So based on that, okay, argument, whenever you create questionnaire, as much as possible, if you want to get the data without losing information, okay, get it the highest value, as much as possible. Of course, when this is called occupation, that must be nominal, that's fine, right? Gender must be nominal, that's fine, okay? But age, cost, travel time, and so on, so put it as ratio. I understand the difficulty of putting the value as ratio. Okay, for example, 15 minutes, okay, or 17 minutes, or 17.5 minutes of travel time will be more difficult to get the data compared to between certain range. I understand that, but at the same time, if you want to get better result, so better as in the ratio type, as much as possible, or interval. Is that clear or not? Why? Because you can always derive from the ratio type or interval type, you can always derive that into ordinal or nominal. Okay? Easily you can derive. Easily you can set the range. But once you ask into interval or ordinal, or even nominal, and then you ask back, where is the actual value? You already lost information. Sayang naman. Is that clear or not? Okay, the meaning of measurement of scale. Okay, go as much as possible to the ratio type, if possible. Okay, later we will see certain technique. Okay, like ASP and Gordon Brown later. Okay, that we can actually estimate or approximate from ordinal to go to ratio. Well, not accurate because we already lost information, but this is an approximation. Okay, so in general, you cannot, you can put down from ratio to nominal, but you cannot go from ordinal to ratio, but you can approximate using model. That's the actual value of that model. Okay, so qualitative data, either nominal or ordinal. Okay, the characteristic is the existence of choice, okay, without order, that is nominal. So in this case, you want to put male as 1, female 2, or the other way around. Female as 1, male as 2. It doesn't matter because the numbering here is just an assignment. Okay, as long as it is consistent, there's no problem. Okay, so in ordinal, yeah, there is an order, there is an index. Okay, so there is a sequence or order of choice. For example, hot, hotter until the hottest. Yeah, this is the example. So if you want to do nominal level of measurement, okay, as much as possible, try to do exhaustive categories and mutually exclusive. That means non-overlapping. Okay, this is the important things. Mutually exclusive and exhaustive. Okay, and you have no meaningful order or ranking can be imposed in the data when your data is nominal. Okay, so I give you example here. The fruit I like is banana, apple, and orange. So you can set any value, 1, 2, 3, or -1, 0, +3, no problem. Okay, the numbers here does not mean anything aside from the assignment. As long as it is consistent, okay, no problem. Clear, yeah? Next, okay, again, gender is nominal variables, okay, with value of 1 male, 2 female. Okay, you can change that in reverse order. For example, oh, I want 5 to be female and 225 to be male. That's fine as long as consistent, yeah, definition. Okay. Next, how about ordinal? Okay, ordinal level of measurement of scale. Okay, is categorical, that can be rank. Okay, so the difference between the rank cannot be calculated using arithmetic. You cannot add, you cannot minus, you cannot multiply and divide. Okay, so these are example of ordinal variables. Yeah, comparison index. So you have -2 is strongly disagree, -1 is disagree, 0 indifference. Yeah, okay, 1 is agree and 2 is strongly agree. So this is comparison index is ordinal variable. Rating, okay, 1 is very dissatisfied, 100 is very satisfied. Again, this is ordinal variables. Yeah. Ranking, yeah, 1 is the best, higher value mean lower importance. Again, ordering, okay, this is also ordinal variables. Is it clear or not? What's the difference between ordering and rank? What's the difference between ordering and rank? Yes. So here I have example of fruit factors, okay? Grape, mangoes, banana, apple, and orange, right? And then this is given, the rank is given. So I like mangoes more than orange. So in this case, mango is rank 1, orange rank 2, okay? Banana rank 3, apple 4, and grape 5. This is given, the rank is given. So in this case, my rank factor become 5, 1, 3, 4, 2. Right? This is based on my own preference. Just example here. So then when you want to put this into ordering, then of course mangoes now number 1, right? Orange number 2, banana number 3, apple number 4, and grape number. So these are the ordering factor. Can you see the difference? Okay, so this is the sequence based on the rank. Okay, and this one based on the data here. Yeah, fruit factor. Okay, so again, in quantitative data we have interval and ratio. What's the difference? Right? Interval data may have plus and minus. You can do arithmetic, plus and minus, but you cannot divide because interval data have no zero. Yeah, so interval level of measurement scale, yeah, the rank data difference between unit of measure can be calculated by arithmetic. Yeah, so 0 in the interval level of measurement does not mean nil or nothing as the 0 in the arithmetics. Yeah, this is the example. Fahrenheit temperature is an interval data. Okay, because you can take meaningful difference of 1 degree between each unit, isn't it? Okay, so but 0 degree of Fahrenheit does not mean there is no heat. Yeah? So, but you can have plus and minus. So 74 degree is 2 degrees higher than 72, isn't it? That not happening in the ordinal scale. For example, here -2 and -1, right? So the difference is 1, right? But that difference does not mean anything. Okay, so between agree and strongly agree, the difference is also 1. That difference does not mean anything because ordinal data you cannot do plus and minus. Arithmetic operation you cannot. Yes. Okay. Is it clear or not? Okay. Next. So for the ratio measurement of scale, okay, possess all the characteristic of the interval, okay, ordinal and nominal. Okay, so this is the highest. Okay, so there is zero. That means real zero means nothing. Yeah. So usually ratio data type exists, okay, with certain unit of measurement. The unit is not necessary, but usually it exists. So let me give you example in here. This is the length. Okay, the block here, the block in this case is the length. A is this short, B is this short, okay, and E is this length. Can you see? So now if we put this into ratio type, this is the actual length, so 15 units. Yeah? This is like 10 units, 8 units, and so on. So these are the ratio type, okay, that you measure by certain units. Okay, but once you put this into ordinal, okay, you just put this 1, 2, 3, 4, 5. Okay. Yes, there is an order that this is longer than this. E is longer than D. Okay, but you already lost information. Once you put from ratio to ordinal, you lost information. The actual length you lost. You get only the order, but you lost the actual. Is that clear? Okay. So, interestingly, okay, these are the examples of nominal. Okay. ID, I color, zip code, no ordinal, the ranking a while ago. Grades, your grades. Okay. The height in tall, medium, and short. Okay. In the sport, you get medal, right? Yeah, Angelo, you want to say something?
Sir, just a question. If you're finding the relationship between different factors and
Mhm.
a nominal data is included, how can you do that in Excel? Since in Excel, it only accepts numerical value. So should you assign a numerical value for each category, or uh, what
Okay.
what what do you
I think
do?
this is very interesting question. Okay. Actually, I have let me find in, in okay. Let me share my whole screen to you. Okay. Let me find questionnaire data analysis in Revolut. Yeah. There. Can you see my screen? The questionnaire data analysis in Revolut. So you can read this tutorial. This is exactly the answer of your question over there. Yeah. So in this example, I have a research question. Okay, so we have family, time, mode, activities, satisfaction, playground. So uh, can you see it? No? Okay, I will send you the link to all.
Thank you, sir.
Go ahead. Go there. Okay, let me share that. Okay. Can you see? Okay, so we have uh, this is simplified. Now this is actual survey that my PhD student last time did in Saga University. But we simplified so that you can see clearly. So there are more than 10 parks in the city. And of course, the actual data is more than 100. So I just put here only 10. And the questionnaire also many questions, but this is only 6. Okay, so family is just observation number. So we send this questionnaire to each family. Okay, time here is quantitative, measured in minutes. Okay, so this is basically ratio time, isn't it? Mode is nominal data. Okay, so in this case, you have only 4 choices: walk, car, cycling, and bus. Okay, and then activities, again, this is nominal, but this is interesting. But in activities, okay, unlike mode, you choose only one, okay, for one family. Activities can have more than one choice. So this is multiple choice, meaning one family may have several activities in the park. Both are nominal, but different way, right? The question is, how are we going to put this into Excel, for example? Yeah, and then the satisfaction is clearly ordinal. Okay, playground is clearly binary. Okay, so this is the one that we want to know. Huh? So this is the data. Can you see the table? Yeah. I have only 12 data in this example. Okay. Time is in minutes, 30 minutes, 45 minutes, and so on. Because this is questionnaire, so they will always answer uh, up to 15 minutes. Even though we asked ratio type, the person is not really accurate because this is questionnaire anyway. So, and the mode is, I put here 1, 2, 3, 4. This is the walk is 1, 2 is car, cycling, bus. Okay, and then activities, we have 6 activities, comma, right? So 1, 2, 3, that means 1, 2, 3 is what? A sport, picnic, and reading. Yeah, and so on. So activities, we have more than one activities. Okay. Minimum one, and then satisfaction to that part, and whether this is a play, there is a playground. Okay, so first thing you want to do is actually create the research question, isn't it? Huh? So these are the general. Okay, what is the research question? So what activity most people do in the park? So what mode most people use in the park? So is there any existence of children playground in the park? Okay, so this one number, if you look at the question, this is question number 3, 4, and 5. What is this? This is relationship between two attributes. Can you see that? Okay, uh, playground and satisfaction, activities and activity time, and then activity time and the mood. Okay, so when you do research, okay, first thing first, okay, remember to create the research question, and then you focus only to answer those research questions. Otherwise, when you analyze, you have so many data, okay, so many analysis, you get distracted. Okay? So now, using that, okay, let's go to the next. This is how you will code, right? This is your data a while ago. Can you see? Right? This is your data a while ago. Out of these variables, okay, there are 2 variables that is actually not yet in numbers. Number 1 is the activity, because this is a sequence, not number. And then playground, this is binary, yes and no. That easy. Binary, just put 0 and 1. But activities, because you have multiple choice, then you need to convert this into binary. Is that clear? You need to convert this into binary. So how to convert this into binary? You create 6 variables, right? 6 variables, because you have 6 activities, so you have 6 variables. Okay, then again you can download this. Now activities become 1, 2, 3 until 6, and then binary means yes or no. Is it clear now? This is answering your question a while ago, right? Okay, now we have in Excel, okay, or in SPSS, if you use SPSS, okay, they always want numbers, right? When you input into computer, they want numbers. So this is how you encode. Okay, and if you have missing value, you put, for example, the number that you don't use. For example, minus 99 or minus 999. So these are the numbers that you don't use as a missing values. Okay. Next, after that, you do analysis of one variable. So Excel, you can do a tool data analysis. So yeah, analysis toolbox. So you get this. And again, because you already set your research question, then focus only to answer your research question. Yeah, these are the three things that actually asked earlier, okay, in the research question. You see here, there are a lot of numbers. If you don't focus, you get distracted. Okay, but once you have a research question, it guides you. And so I put here, be focused only on your research question. Okay, with that, now you can extract the result of the analysis. Okay, so these are the sample, and then you can extract certain things. Again, always focus on answering your research question only. Okay? If you don't, then you create your new research question. That's fine, no problem. It's an iterative process anyway. Right? Oh, I want to have this. Again, new analysis you can put in. Okay, as long as it answers certain research question, and then with that you can answer one by one. Yeah. What activities most people do in the park? Oh, apparently picnic. Yeah, based on this analysis. Next, of course, the next analysis is to do cross tabulation, right? So in Excel, you can do cross tab, or in SPSS. So cross tab in Excel is called pivot table, right? So you do analysis of pivot table. Yeah, these are the wizard of pivot table in Excel. You get highlight the data that you are encode, and then you just drag and drop, okay, the things that you want to analyze. Okay. Check this. The data is there in the Excel, in the website. You can download. You can practice on your own. Okay. With that, now you can get what kind of analysis you want to do. Of course, again, focus on the research question only. Okay. There are so many combination of analysis that you want to do, but if you don't have research question, you get distracted. If you have research question, you only analyze to answer your research question. Okay. A while ago, we want to check the relationship between playground and satisfaction. Then you just do that. Okay. You get this result, and then you can do a chi-square test. Okay. Okay. You can read on your own here how to get the chi-square test using Excel. Yeah. So all of this in Excel you can practice. Yeah. I think you already learned this in statistics, no? Chi-square. Do I need to explain this or?
Thank you, sir.
Yeah. So chi-square test is to check the relationship between two variables in the pivot table. Yeah, whether they are actually has a relationship or no relationship. Okay. With that you can answer this question. Yeah. Okay. Back to in the year. Let's see. I want to say something.
Just curious, sir. I see the satisfaction measurement. You're using a Likert scale, right?
Likert scale is ordinal.
Yeah. Just one more question, sir. Uh, in Likert scale, sir, is it okay if you don't put a number that represents neutral answers?
Yeah, it's okay. So ordinal value, you can put any value. For example, in Likert scale a while ago, I put -2 until +2, right? And then with 0 in the middle. If you don't like that, for example, you have only 4 answer without indifference, that's
Yes,
fine
yes.
also. Right, no problem. And then the value is not necessarily minus and positive. You can put 0 to 4 or 1 to 5 or 100 to 500. That's okay. Again, the numbers does not really matter there because this is just
Yes.
assignment. Okay?
Yes, sir. But what I was asking actually is, like if you have four categories like um highly satisfactory, satisfactory, dissatisfied, or highly dissatisfied. There's no middle. Like there's no middle. There's
No
no
problem.
neutral. That's
Yeah,
no problem. Okay.
no problem. So in that case, you set for example, 4, 3, 2, 1.
Yeah.
Yeah, no problem.
Okay. Thank you, sir.
Yeah. So let's come back to the measurement of scale first, so that you can get the idea of what kind of analysis. Okay. Can you see there? Yeah. These are the example. Okay. Ordinal interval ratio. Now, this is the power of measurement of scale. Okay. Nominal level is the lowest level. Okay. It is the least powerful. Okay. That provide the least information. Ordinal is higher, followed by interval, and then the ratio level is the highest. Okay. So again, any data conversion from the higher level of measurement scale to lower level of measurement scale, you will lose information. You can go down, but you cannot go up. Clear? Yeah. Now, yeah. Now, this is the characteristic, yeah, the properties of attribute value. Yeah. So, 4 things. First is distinctness, whether they are equal or not equal. Order, larger or smaller. Addition and multiplication. Yeah, these are the properties that we put here. So nominal value, nominal measurement of scale or nominal attribute, okay, will only have distinctness, okay, whether they are equal or not equal, but it has no order. Ordinal attribute have distinctness and order. Remember, when you have qualitative data, okay, you have distinctness or ordinal, yeah, or nominal or ordinal. Now, in interval attribute, you have the 3 of them, yeah, distinctness, order, and addition. Yeah. When I said addition, that includes subtraction. Okay, and it is the ratio attribute that have possess all these 4 properties: distinctness, order, addition, and multiplication. Because of this is the important here. Next slide. Because of this, okay, so if you have nominal data, you cannot measure mean. You cannot measure median. All the things that you can do is only measure mode. Look at this last column here in this table. Okay, you can calculate entropy, you can calculate contingency and correlation, or chi-square test a while ago. Okay, if you have ordinal data, you can, of course, you can do all the nominal, right? And then you can do median. You can do percentile, run correlation, yeah? Okay. If you are nominal, you only can get contingency correlation. If you are not ordinal, you can do run correlation. You can do run test, sign test. Okay, but you cannot get standard deviation in ordinal data. Don't do standard deviation if your measurement of scale is Likert scale. Okay? So, interval and ratio, okay, can do all of this operation. Yeah. In ratio type, you can do a geometric mean, harmonic mean, and percent of variation. But if your data is interval, you cannot do this geometric mean because there is no zero. Is this clear? Okay. Interesting, right? So next, you can do transformation. Yeah. So yes, you can do transformation in ordinal data as long as, okay, as long as the order is preserved. Yeah. In nominal data, you can only do permutation. Yeah. In ordinal data, you can do change of the function as long as it is monotonic function. Okay. In interval and ratio, they are basically numerical already, so you can do all the things that you want. Okay. Up to here, is it clear? Especially you need to make sure, okay, on ordinal data. Why I'm talking this? You can measure anything, okay, including faith. Can you measure faith? Yes, faith can be measured using ordinal data. Can you measure love? Love. Sarangi. uh, yes, you can measure love by ordinal data. Okay. So, how much is your love? 0 to 10, Likert scale. Right? Your faith can be measured 0 to 10. Okay. It's not nominal, okay, but it's ordinal data. Okay. You can put score. Okay. You probably cannot do it as numeric interval and ratio, but you can always measure using ordinal. Is it clear? Yeah, interesting. Okay, so these are the yeah. If you want to know whether okay, so if you want to check whether this is nominal, ordinal, interval, and ratio, you can use this decision tree. Nah? So whether they are ranking or not, yeah, whether it has arithmetic operation or not, it has arithmetic zero or not. So with this three question, you can check whether they are nominal, ordinal, or ratio. Okay, so this is the summary. Nah? So your data can be qualitative or quantitative. Okay? In qualitative, you have nominal or ordinal. Okay? In quantitative, you have interval or ratio. Okay? That can be discrete or continuous. Okay, up to here. Is there any question? Comments? I know you already learned this, so probably this is just to deepen your understanding. Right. Next is in the slide. Oh, run reversal. Okay. I don't have slide on run reversal, but I have the text, so you can read. I'll just summarize this now. So in this text, can you see the text? Okay, say suppose I have 5 charts, okay, A, B, C, D, E, and then I have 10 items here. Yeah? and then each chart will give the score. Okay, 1 to 100 for each item, and these are the score, right? So we consider each chart equally expert, so the weight are equal. Okay, so in that case, we just sum this and then take the average, right? Okay, once you get the average, and then you rank that, yeah. So the highest average will be rank 1, okay, and then the second highest will be rank 2, and so on. Okay, now this is happening, yeah, in that competition last time. So suppose we have another scenario that the judge want to use their rank instead of their score, right? Some people propose something. Oh no, I want to do, instead of scoring like this, because we take the sum, I want to do ranking. Okay, so in this case, for each judge, we do the ranking. So you see here, say judge A, yeah, you see item 6 is 100, right? And then, so this one we give rank 1, that, yeah, and so on. So this score rank is based on the above scoring, okay? But now instead of score, you do ranking. And then of course, you want to aggregate this, right? When you want to aggregate this, you do the same thing because you have the same weight. So you take the sum and then you take the average and then you rank that, okay? But if you do this, you see the aggregate of the rank, okay? Yeah, number 1 is the same, but number 2 probably the same, but number 3 and 4, is it the same? Not the same, yeah. So there are some items will have reverse order in the rank, right? So this is called rank reversal, yeah. So this is a problem of rank aggregation, yeah. If you use ranking instead of the score, okay, you will not get the same rank. Yeah, some rank will reverse. For example, item 2, yeah, supposed to have rank 9, okay, now become rank 8. Okay. Rank item 4, supposed to be rank 7, now go down to rank 9. So, okay. So then, in this case, what is the suggestion? You score. The more you aggregate, okay, you lost information, correct? So try the same as ratio and interval, ordinal, nominal a while ago. Okay, the more you aggregate, the more you lose information. So try to make it the highest as possible, okay, before you aggregate. That's the lesson. Yeah. Based on the score, based on the rank, they are not the same. Okay. So I put here the simple lesson is use score aggregation, not rank aggregation, because it may lead to rank reversal. Okay. Next. Oh, before you go to Brown, Gibson, and ASP, is there any question, comments? No? Okay, good. So I have okay, let's go to MCDM first. Yeah? MCDM. Okay. Can you see the slide? Yes. Okay. So again, our goal is to prioritize. Okay. You can go to this tutorial, yeah, in Revoledo, ASP. Okay. so that you can get the text, this slide. Okay, this is just the summary. Okay, so we want to do decision making, MCDM, multi-criteria decision making. Okay, I'll discuss about the example of goals, criteria, and alternative, and then I will discuss about transformation and normalization, and then certain techniques. Yeah. Okay, so I hope by the end of this slide, yeah, this lesson, you should be able to make decision based on criteria and alternative, and then you can say the different simple technique and multi-criteria decision making, and then you can quantify your subjective opinion, right? You can quantify subjective opinion. So in any decision making, it is a process to choose among alternative based on multiple criteria. So in any decision making, you always have alternative. Yeah. So the most important is you have alternative. So alternative means the choice that you want to decide. Okay. If you have no choice, so you don't need to decide. Right. Okay. But you always have choice. Okay. Remember, you always have choice. Okay. Sometimes the choice is not optimum, but you always have choice in life. Okay. So this is philosophical anyway. So criteria mean the factor that you want to consider and always have goal. Okay, so I give you several examples. Say you want to decide the best office space. Then you have certain criteria. So these are the criteria that I set up. Okay, so the floor area, closeness to customer, visibility, size, and so on. Okay, and then these are the alternative, the name of the available vacant space in the vicinity, for example, the name of the street. Okay, next, you want to decide the best school. Okay, then you can set your own criteria, isn't it? Or probably based on reputation, distance, the cost, the teacher kindliness or reputation, and so on. And the alternative is the school name that you consider, correct? The same thing, you want to define the best apartment, then these are the criteria, and you list the apartment. Okay. If you want to select the best politician, probably these are the criteria that you want to select, right? And the list of candidates, right? Again, if you want to select your thesis topic, okay, these are probably your criteria, and of course you create the brainstorm, the list of thesis topic, right? If you want to buy the car, again, you have the criteria, price, service, comfort, status, and so on, and the name of the trademark, yeah, of the car. Okay, if you want to buy or rent a machine, again, you put all the criteria that you want, and then probably the alternative is to buy or to rent. Right. Again, in any decision making, you have the goal, you have the criteria, and you have the alternative. Okay, so the limitation of MCDM is it is only best at that time because we have limited knowledge, isn't it? Okay. Again, normally the list that of alternative that we put is not exhaustive. Yeah? It's only feasible alternative that you can think of at that moment, and usually you have only major criteria. Yeah, usually not more than 7, isn't it? Because more than 7 you get confused. Okay. So now for your practice, can you, each of you, okay, set a problem that you want to decide state the goal of your decision, list the criteria of your decision, and then what are the list of alternatives. You need some times? Okay, I will wait. Okay. Again, yeah, you have the goal, you have the problem, you have the goal, criteria, and then the alternative. Okay. Write it down, and then okay, I will wait for how many minutes? 3 minutes. Okay. So you can put any example only. So can be trivia, no problem. Okay. No worries. This is just practice. Yeah. Go ahead and share your screen. Yeah. Big. Okay. The goal is to buy a new phone. Yeah. And there is a budget and storage capacity, camera quality, and what is the weight? The weight means how heavy it is.
Yes.
Okay. Yeah. Okay. Great. Super.
Okay.
Okay. Uh, Now, based on this, okay, the list of criteria, and so you can start to create a table of decision making, okay, and you can put score. Okay. Just give several alternative, and then you can put the score. Okay. Anyone else want to share screen? Your
So
chance.
can I share screen?
Yes, yes, Katrina. Oh, okay.
For example, sir, the congestion of a certain location. And
mhm,
then the sample criteria are travel time, travel speed, and queue length. And
okay,
strategies may be the following, maybe but not limited to number
okay,
coding, congestion pricing, or traffic rerouting.
okay. So in this case, you need to fix the alternative strategies. Okay.
Mm-hmm.
The last one, among others, is you need to fix that. Okay,
Okay.
good, good. Okay. Any other examples that you want to set? Anyone? Last chance. Excellent, Katrina. Anyone? Going one, going two. Okay, going three. So, uh, you can have subjective values or objective values, isn't it? Right? So, not necessarily objective only. So, it can be subjective opinion. Okay. So, for example, preference or satisfaction, important, and so on. Okay. Uh, Usually, subjective values are categorical, either nominal or ordinal. So, yeah, if it is ordinal, so very important, okay, you need to have transitivity, meaning if A is larger than B and B is larger than C, then A is supposed to be larger than C. Transitive, right? So this is a very important axioms, okay, to say that this is logical. Otherwise, it is called inconsistent. Okay. Now, next, the upper bound and lower bound value usually will indicate the best to the worst, respectively. And then your criteria should be independent among one to the others. Next, you can also do objective values. So usually objective values have units. So cost, benefit, time, distance, speed. Frequency is also ratio type. When you analyze some data, for example, from nominal, and then you count, right? How many times it happens, that called frequency, yeah? How often it is. So that one is also uh, objective values. Yeah? So next, what is the problem with objective values? Okay. Units. Yeah? Each criteria may have different units. Okay? And if each value have different units, then it may have also different utilities. I give you an example. Say you want to increase the floor area from 500 meters square to 1000 meters square. Oh, maybe this is attractive to the decision maker. But when you want to increase from 1000 to 1500, okay, the increase is the same, right? Only 500 meters square. But from 1000 to 1500, it is marginal. It is less attractive. Okay. So the utility is not the same, even though the value is the same. So in that case, two solutions. Okay. One is to normalize to the value of 0 to 1 or 0 to 100. Second, you need to transform that objective value into subjective utility, yeah, in terms of attractiveness. Instead of 500 to 1000, then you create it into subjective opinion. If you want to measure the utility rather than the actual objective values. Is that okay? So then you ask, how I will transform that? Okay, so there are several functions that you can use. This is example of function. This is called decreasing function and this is called increasing function. Yeah, these are example of function. You can create your own function. Okay, you can go to this website to about the text to explain about this. Yeah, so by transforming your values, okay, using this transformation, you're supposed to get some kind of normalization. Okay, so let's discuss what is normalization. Okay, it's a process. Normalization is a process to transform your index, okay, either objective or subjective values, into a range of value which is between 0 to 1 or with 0 to 100. Okay, so I can use notation of dissimilarity. This is the original and then this is the normalized. Sometimes I use U here. So the principle is simple. Okay, normalization is an aggregation, data fusion, of the sequence of numbers. Okay, so if you want to do normalization, number one, you make them positive. Number two, the denominator must be bigger than or equal to the nominator. And then you can use any inequality to normalize the index. Okay, these are the principles to do normalization. Okay, I will give you an example. So for example, I created this function. Okay, I created this function as normalization. So this is the value t that I want to normalize. Okay, and then I put a here as any parameter as long as this is positive, right? Okay, so and then I can put the difference between the original value and the normalized. you will see this is between 0 and 1. Okay, so for example, D is -4, A is 100 here, you will get the value of 0.6, right? So using this function, you can normalize to get the range between 0 and 1. How do I create this function? Again, based on the principle, right? That means I have sequence of data, numbers in this case, okay, and then make them positive. And then the denominator must be bigger or equal to the nominator. So you see this, okay, I can make them positive, any value here, and then this one, the nominator compared to denominator, because I add A here, this must be bigger than this, right? So if you have boundary, okay, if you already know the minimum and the maximum, that's easier. So this is the normal way to do. Say, you just minus with the minimum, and then you get the range, which is the maximum minus the minimum. Okay, then you will get this function. This is the very simple way to normalize any value. When you do minus with the minimum, and then you divide by the maximum and the minimum, the range, okay, you will get, well, this delta here will be between 0 and 1. Is it clear? The meaning of normalization. And why do we normalize? Because they have different unit, they have different range, right? So you need to normalize so that they will have exactly the same range, so that you can combine, so that you can aggregate. Remember, you have many factors, many attributes, right? If you want to combine, okay, if you don't put it in the same range, okay, the one with the higher range will get bigger weight. So this is not desirable. So normalization is to make them fair. Okay. So if your value is between 0 or 0 or positive, okay, then your maximum value is unknown, right? Then you cannot use this function, right? In that case, you can just divide by the sum. And this is one way to do. Yeah, you just divide that value with the sum. Okay. How about if it is negative value? Again, you can just take the relative absolute value, and then you divide by the sum. Okay. Or you can square them, and then you divide by the sum of the square. This is called Curtis normalization. So this is a pair normalization. So if you have a pair of indices, yeah, which always between 0 or positive, yeah, or both, okay, but cannot be 0 at the same time. So D1 and D2 cannot be 0 at the same time. Okay. Then you can use this simple formula, okay, to get the normalize. Okay. This normalization will produce range between -1 to +1. Yeah. If you remove the absolute operator. If you put the absolute operator, will become 0 to 1. Okay. So example here, I have two indices, okay, 5 and 7. Okay. Then you just compute, yeah, 5 minus 7 divided by 5 plus 7, right? So this is 2, this is 12. So in this case, 1/6, right? So remember, even though your value is any value, if you use this, because you have two values, okay, then your delta here is always between 0 and 1. Is that clear or not? Yeah. So now, if your value is not numbers but rank, okay, if your value is not numbers but rank, so how are we going to normalize? Okay. So here it is. Yeah. So if you have a Likert scale like this, no? So Likert scale original value is between -2 to +2. Okay, then you can convert this into rank. Okay, so for example, 1 to 5. Okay, so the maximum rank is R, capital R here is 5. Okay, and then you use this formula to convert them into 0 and 1. Okay, so 1 now becomes 0. Uh, R minus 1. This is the R value. So 1 minus 1 is 0 divided by 5 minus 1, right? So it becomes 0. So using this formula, you can normalize any rank, okay, into the normalized rank of 0 and 1. Okay, now about normalization, is there any question? Is it clear or not? Yeah, thank you. So, really, no question, no feedback? Do you know the goal? Okay, you want to put any value that you put in the score, okay, whether it is objective or subjective value, into value of 0 and 1, between 0 and 1. Okay, that's the meaning of normalization. So then the MCDM technique, okay, let's explore several techniques, yeah, so that you can see. If you do a simple cross tabulation, or you use the rank or normalized factor, or you can use weighted criteria and normalized factor. Okay, say if you use cross tabulation, okay, this is the simplest way. So in here, each row is the factor, each column is the alternative, the choice. Okay, and then you have score value in the each cell of the table. Okay, then what you will do, you just sum the score of all factors, okay, and then you normalize that score, right? So here is example. So I have 4 factor A, B, C, D. Let's say you have 3 choices, X, Y, and Z. These are the alternative, right? And look at this. Factor A have range from 0 to 5. Factor B, you have range from 1 to 100. Factor C, you have range between -2 to +2, and this one is normalized 0 to 1. Okay. If you sum all of that, and then you normalize, is this correct or not? Is this correct or not? Normals is easy, no? So you just sum all of this divided by the sum, right? So 19.4 plus 74.75, and then 66.4, you add, become 150. So 19.4 divided by 150, that is 12.9, right? So in this case, if you check the normal score, you will say, oh, the highest is Y, right? 49.7. And then the second highest is Z. And then the last choice is X. Right? So you will say Y is larger than Z is larger than X. But question is this correct or not? This is not correct. You know why? Because they have different range, right? So when you sum like this and then you normalize, what happens is factor B will be dominant because they have a larger range here. Can you see? Okay, so this is the example. Okay, that is bad example. Okay, so don't do this. Okay, Why? Because they have different range. And then you sum all of that, even though they have different range. If they have different units, okay, from centimeter to meter, suddenly you have different rank, right? So this is not the way to do multi-criteria decision making. This is the wrong way, okay? So, because you have a different range for each factor, okay, you can put your own subjective score and can you compute the preference of your decision alternative. A while ago, I asked you to create that, right? So, can you do your own practice, okay, to put your own score? So, it's a problem. Why? Because now we don't know higher is better or smaller is better. Okay? For each factor, you need to check should have the same consistent. Yeah? That higher is better or actually lower is better. This is first thing. Second, each factor will have a different unit, right? So then if you change the unit, it may change the score, it will change the weight, and then it will change the decision. So it's a problematic. Okay. So again, higher values, okay, and wider range will have dominant weight automatically if you use this. So don't use this kind of technique. Okay. So what is the solution then? Normalize. Okay. So you normalize so that they have the same range. Okay. So that they have the same range, and then you need to put consistency. Okay. Whether they are benefit or actually cost. So that higher is better. Okay. Not lower is better. And then you need to put weight in each factor. Okay. So sometimes you will say, oh, in that case, I can put run because this is already consistent, right? Okay, so this is the next technique. Yeah, next technique is to use run. Okay, so here is the run. Factor A. Okay, the run is 1, 2, 3, isn't it? So this is a run-based technique. So you for each factor you put run. For factor A, choice Z is rank 1, choice Y is rank 2, choice X is rank 2. For factor B, choice Y is rank 1, okay, and so on. So if you sum the rank, right, and then you normalize, again you normalize. This is the way I normalize this value. Okay, so I get the sum and then I get the total sum. Yeah? 11 plus 6 plus 6, right, is 23. So for the X here, I get 0, half 1 minus the sum is 11, okay, divided by the sum of all of that, which is 20. Okay? So then you can see that the normalized score, that means this X, Y plus Z, yeah, is 100. Correct? So this is normalized way. So, well, using this technique, rank based, okay, now the decision is changing, you see. Now Y and Z is larger than X. Can you see the decision? Change. Because this is equal weight. Huh? So remember in rank, lower is better, isn't it? Okay. So for your own practice, you can transform your objective score into rank, okay, and then you compute the normalized score. Yeah. How to normalize the score of each factor? Okay, using rank, okay, it seems like problematic. yeah, because the rank itself is unclear. Okay, it's very aggregate, right? You lost a lot of information. Okay? Then, if I have a score value instead of rank, can I just normalize its value? Okay, so this is the way to normalize. So you have the original value. Okay, this is the lower bound and upper bound, right? And then you have also the new upper bound and lower bound. Okay, then you can use this formula to transform your score into 0 and 1. So in the next technique, okay, you transform the original value a while ago, it is in this case, this one, this value, simple score, into 0 and 1. Okay, because the range is already given 0 and 5, right? So you can use the formula a while ago to make it into 0 and 1 for each factor. Okay, so this is the one that you get. So for each factor, now you get the value between 0 and 1, right? So with this, now you have a better result. Huh? So now you say that the y is actually larger than z and then larger than x. So this is the one. Okay, you practice, huh? So that you can get the result. Okay, so you need to practice so that you can get the result. The last part, okay, we can use weight. Okay, so you can create subjective judgment, okay, based on the importance of each factor relative to the other factor. Okay, so in this case, you can create pair comparison, yeah, to normalize the judgment, and then you divide by the sum of the judgment. Yeah, I give you example. Yeah, suppose factor B here, okay, and C, okay, is actually 2 times more important than factor D, right? And then factor A here is 3 times more important than factor B. So these are the subjective judgment that you. In that case, oh, I can put the value. Okay, D is 1, B and C is equal, 2 times more important, so I put 2. And then A is 3 times of B, so 3 times 2, 6, correct? So, and then the sum is 11. So in that case, now the weight, the important weight is based on this. Now 6 divided by 11, 2 divided by 11, and 1 divided by 11. So of course, this is just normalized, so the sum is 100. Okay, so this is to decide the weight for each criteria. Is this clear? Hmm. So based on this, now you have the weight for each criteria and you already normalize, right? Then you can use all of that together. Okay. Oh, if you have many criteria, okay, how to reduce the number of comparison? Okay. So if you want to have a reduced number of comparison, first you sort the criteria in the order from the best to the worst. Okay, and then you put the best factor as 100. Okay, and then you compare the worst factor, okay, to the best factor, and then put the score in terms of percentage. Okay, and then you repeat again based on that factor, yeah, to the best factor, and then you normalize eventually. I give you example. Suppose you have this is the value. Yeah? The sort of order of importance is E larger than C, larger than D, larger than B and A. So these are the value. Okay. So and these are the weight that you already set. Okay. So then you see the best is E, right? So then E you put as 100. Okay. Then you ask to yourself, if I compare C to E, yeah, if I compare C to E, remember pair waves comparison, right? So you only compare two at a time. Okay? If I compare C to E, okay, how much? If E is 100, how much is C? Oh, you will say, oh, that is 80% of E. Okay? And then you compare. If I compare D to E, oh, that is 70%. If I compare B to E, then you say, okay, this is 60%. If I compare A to E, then you say this is 40%. So you don't need to compare D and C. You don't need to compare D and A because everything compared to the highest, which is in this case E. Okay. Now if you put all this weight that you already compare based on the pairwise comparison, you take the sum and then you just divide. Yeah? So 100 divided by 350 is 29%. Is this clear? Any question? So finally, what you need to do is, okay, this one. Yeah, this is the correct one. Yeah. So first, you normalize the score of each factor, and then you use the weights for the normalized judgment, and then you use the score based on the sum product of the weight and the normalized score. Yeah, something like this. Okay. So remember, for each choice, okay, the sum must be 100. For each factor, the sum must be 100. Okay? This one or 1 here. Sum must be 1. Okay. And then you get the weight, and then you get the sum. And after that, you can normalize it. Based on this normalization, then you get the decision. Is this clear or not? Initially, okay, look at this. Initially, this is what you have. So that you can understand. This is what you have. Initially, this is what you have. Okay, but this is the problematic. Why? Because the range is not the same. Correct? The range is not the same. So this is not correct way to do. So, okay. So the best way to do is you normalize of each of these and then you get the weight. Okay. So how to put the weight, how to put the score, normalized score. This is the one that I just explained a while ago. Okay. This is the final answer. So for your practice, okay, for your own goal and alternative and criteria, okay, can you do similar to this? Yeah? You calculate the normalized score for each alternative, okay, and then you get the normalized weight. Okay, up to here. After that, you can do sensitivity analysis. You can talk about it next time. So this is the summary. Okay, of MCDM. Okay, so next meeting we will discuss about AHP and Brown Kit sum. in Moodle. You can check the slide first. And after that, if we have time, we can go to the financial analysis. Is this clear, today's lesson? Can I give you assignment? Yeah. So the assignment is simple. You create your own goal and the problem, the goal, the criteria, and the alternative that you want to decide. And then you put your own score at different range. Okay. And then finally you normalize all of this. Okay. And then you create judgment of each factor. Okay, just MCDM. Is that okay? So of course everyone will be different, right? Okay, so that you can have practice at home. Thank you for today.
Thank you, sir.
Yes.
Thank you po.
You,
Thank you, Prof.
you.
Right.
I will